be looking at creating some equations from pieces of of hyperbolas. This is going to be a very reminiscent of what we did with the ellipse. It's just we're going to be using different equations. So I'm going to kind of work through a number of these. So follow along, and then what you can do afterwards, you need to pause it and try the other one that I'm going to have that's just the same, or you can watch them all and then try it after the whole video is over, and you can kind of come back to it as you need to. Okay, number one, remember we're going to be looking at trying to find the center. We're also going to be looking to find how long A and B are, as well as the orientation of the ellipse or the, the hyperbola. The vertices, I can again look at which one's changing, and this is going to tell me which direction that hyperbola is going to be opening up. Since the x is changing, it means the parabola is, or the ellipse, or gosh, the hyperbola is going to be opening up left and right. I always use the make a notation like that just to kind of remind myself. The center of this is going to be found by using the midpoint formula. So if we don't remember that, it's pretty easy to remember. You're just basically averaging the 2 points together. So x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So that's going to give me my center, especially when I have something like this. I don't have any other like locational value, and I don't have conjugate x's endpoints, or I don't have anything else. So I think this is probably one of your easiest ways to find the center. We obviously know that the y coordinate of the center is going to be -3. We just don't know what the x one is, right? So we'll go ahead and kind of put that in here. We'll go over here. It's going to be 1 plus -21 over 2. I'm really not going to worry about the y part since we already know what it is. So we're going to be doing -20 over 2 to give me a -10 x coordinate. So -10, 3 is my h and my k. Now, from knowing that it's left and right opening, we can kind of go ahead and write out that initial equation. X comes first since it's left and right. So x minus -10 squared divided by whatever a squared is. We'll come back to that in a minute. Minus y minus -3 squared over whatever b squared is, and that's going to be equal to 1. Good news is we kind of already know what a squared is. How far is it from my vertex to my center? So I can look at any one of my 2 vertices. So how far is it? I can do some subtraction. 1 minus -10, so we can do that here. So 1 minus -10, that's going to give me a distance of 11. So notice I went from the vertex to the center. That's exactly how far apart they are. If I subtract the vertices, I could do the same thing that way. In that case, we would have said 1 minus -21. That would give me 22. We know that the distance between 2 vertices, right? So if that's a vertex and that's a vertex, the distance between both vertices is 2 times a. That's the transverse axis length. So we could divide that by 2, and I would still get 11 is equal to a in both situations. So it doesn't really matter how you want to think about it. It is very good for you to understand the relationships between all of the points and their center points. So a is 11, so we're going to put 121. Next, we're going to look at our second piece of information. The conjugate axis is 16 units long. The conjugate axis is equal to 2 times b. So we'll divide that by 2 on both sides. We're going to get that b is equal to 8. So b squared is 64. And this completes the equation. Remember, it's not a matter of getting every single fancy thing out there. I just need to get the center and then a and b, and then know which direction it's going to be working with. All right, so you can try that next one, number 2, just like this one. Let's look at number 3 now. So just like last time, if I have vertices and covertices for the ellipse, I can see the center point. We don't really call these by a particular name, but they serve in the same fashion as the ellipse. Covertices, we can see that -4 repeats here, and we can see that -10 repeats up there. So that would give me a really easy way of finding the center. That's going to be -10 and -4. I can also kind of go ahead and look at A and B by noticing the difference, the distance between the two. Here again, I can look at the distance between two vertices, and so this would be a -8. So this would be 0 minus -8 gives me just 8. So divide that by 2. That's going to be 4 is equal to A, because A is the distance between vertices. I'll do the same thing with the endpoints of the conjugate axis. Take the two different ones, -8 minus -12, which is going to give us -8 plus 12, which is also 4, which is what B is. So in this case, we're going to have A and B equal to 4 in both situations, which is totally fine. Vertices are the y coordinate is what's changing, so this graph will be opening up and down. So we're going to put the y part up front. So y minus -4 squared over something minus x minus -10 squared over something equals 1. Now, A and B were pretty easy to find. In this case, I don't even if I get them wrong, they're the same number. It's going to be 16 here and 16 there. It's pretty easy when you're given something like this. The vertices and covertices, or the vertices and the endpoints of the conjugate axis, they pretty much lead you directly to the three values you need: the center, A, and B, and then of course you can tell which way it opens up. So that's a really pretty easy one to get. You really want to get something like that. Let's go down and look at number 5. 5, if you remember from the ellipse, when you have these awkward radical involvements, it means that I'm getting a lot of things kind of for free. So let's list out what we're getting for free. Number 1, what you can see just by looking, you see here, 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 here. You can see that kind of pop up inside of each coordinate. We can see that they're using the 10 and 8, and they're adding and subtracting different radical values to it. So if you kind of ignore the radical values, it is telling you the center point. So center is equal to 10, 8. And also, A, unfortunately, in this problem, is not a very nice value. A is the 5 square roots of 6, and C is equal to 10 square roots of 2. Remember that the vertices always have to do with A, and foci always have to do with C. There's always a C right there in foci, so that kind of something you can kind of connect to. Okay, so I'm looking at the vertices right now, and I can tell you that the x coordinate is what we're adding and subtracting that 5 square roots of 6 to. So that means the x part is changing, so the graph is going to be opening up left and right like the x-axis. So we'll go ahead and write that in. X goes first, since it's like the x-axis. X minus 10 squared over, I can go ahead, I can write, if I square both sides here, I can find out what that is. It's going to be 5 squared times the square root of 6 squared, so it's going to be 25 times 6, which is going to give us 150. So you obviously know that when you have a situation like this where you have radicals involved, it means you're probably not going to have perfect square values in the denominators. So I'm going to kind of move down a little bit. I don't have the next part. It's going to be y minus 8 squared divided by b squared, which is what I don't have yet. So we're going to go ahead and say 150 plus whatever b squared is equals, if you square the 10 squared, you get 200. No, sorry, you get 100 times the 2, which is 200. Get ahead of myself. So clearly you can see here we're going to subtract 150 from both sides, right? And we end up with b squared equals just 50. And that's all I needed to be, not b squared. All right. Sorry for the diagonal writing here. So there you have one where you have that. And for the most part, whenever you get these radical things happening, I count that as a blessing, especially since I only have to square them. It's really easy to square them. And let's be honest, your calculators will do most of that for you. So even if you're not really thinking about it, you can always make it work out. I would say that if you think you need a calculator for this, you probably don't. I haven't pulled one out the whole time, and there hasn't been a lot of big number math. But don't be afraid to pull it out if you really need it. We're going to kind of go down to the bottom. In this example, the formula sheet that you got on Friday is going to be pretty crucial. I'll put a link to this on the page where this video is if you were absent or if you didn't get a copy of that, if you just need an extra copy or whatever. The vertices, again, I'm going to kind of look at those to start off with. The vertices have an x-coordinate of -3 for x. So the x-coordinate is -3. If I look at 8, we can go ahead and add these together. So it's going to be 8 plus -10, all divided by 2. That's going to give us -2 over 2, or -1. Remember, it's addition divided by 2 gives you the midpoint. Subtraction divided by 2 gives you the distance from the midpoint to one of the sides. That's how we find A in this case. So now I already know my slope is either A over B or B over A, depending on which one we're looking at. We have the y coordinate kind of going up and down. If we look at the equation for the hyperbola, you can see it below, or specifically the asymptote, although this is totally misspelled. The asymptote equation, we're working here. My vertices are vertically above each other, so you're having a vertical transverse axis. So this is my equation. What I really want to focus on, I don't really care about the constant value. I care about the slope. I know that the slope of my equation is going to be A over B. So I know that A is 9 and B is 11. If you know what you're looking at, that's actually a really nice shortcut. B is 11. A and B are always going to be positive values because they're representing distances. Even though the slope is going to be a negative and positive, don't let that kind of throw you off. That comes from the equation inside the ellipse down here. And so if you kind of wanted to double check yourself, one of the ways you can do that is you can look at the vertices, right? I can subtract these 2 points, 8 minus -10. If we do that over here, 8 minus -10, that's equal to 18, divided by 2 would equal 9, which is what we would call A, because that's the distance between the vertices, or the vertex of the center, I mean. And we can double check that we found A to be 9 as well. So even if you kind of double check, or maybe you want to have some way of double checking, that's the great way to do it. So we can kind of go ahead and write the equation out. It's going to be y first, because it's going vertical like the y-axis. So it's going to be y minus 1 squared divided by a squared, because a is always first in the hyperbola, 81. And then it's going to be minus x minus -3 squared over 121, which is equal to 1. So take your time with these. It definitely helps to know the shape. I was using a lot of references to how far apart things were. And what I was doing was I was definitely talking about the distances between the vertices and I guess what we would call the distances this way with the endpoints of the conjugate axis. If you are comfortable graphing these, it will most definitely make this kind of expression or these examples a lot easier to work out. If you have questions, please kind of rewatch those video parts and we'll go over this tomorrow. I wanted to do one more before I end the lesson. Number 13 and number 14 are graphs. I think these are probably easier. I just wanted to make sure I went over the pieces here to show you what you're specifically going to be looking at. Number one, visually representing the graph is, you can see that axis you're talking about, it's going up and down. So that means that you're going to have y minus h, y minus k squared, excuse me, minus x minus h squared over a squared and then over b squared equals 1. So if the graph had been going left and right, I would have swapped the x and the y, but now we can kind of see everything. So hk is my center. That's really obvious. The black lines are the asymptotes. They're not actually part of your graph. The blue lines are. I know on your paper you can't tell the difference, but you can here. And so here you can see that that dot is exactly 3, 0. Now I can count from the dot up to the top part. So we can kind of go from here up 1, 2, 3, 4. Or I can go down 1, 2, 3, 4. And that tells me exactly what my value for A would be. From the center to the vertex is exactly A. For B, it's easy to see that I can go over here and I can look where I'm going to draw a horizontal line right there where the vertex is. And that's going to cross over those asymptotes, right? And if I take those asymptotes and I can, where it touched the asymptote, I'm going to draw a vertical line right down the line here. And what you can see here, that's going to create that little box that we would have made to graph the whole thing. And if you remember, the distance from here over to the top of the box, in this case to the left or to the right, that distance we would travel is exactly what B would be. That's the conjugate axis. In this case, that makes B just one step. And if you look at number 14, you're going to notice that B is going to be a lot wider than it would be in this one. So we can go ahead and rewrite this equation as y squared, or y minus 0 squared is totally fine, over 16 minus x minus 3 over 1. And again, if I have a 1 that's on the bottom, I don't have to write the 1. Or if I have a 0 that's being subtracted, I don't have to write that 0. And this would be your equation. Okay? Hopefully that was easy. Hopefully you kind of realized what to do. I just wanted to make sure to go over this specific part about how to find the box. Just draw that horizontal line through the vertex. If the graph had switched over, then those would be vertical lines. And then I would kind of follow along where it hit that asymptote. And we're going to kind of draw that line down. And that allows you to see the box, which allows me to see the A and B distances a lot clearer. All right, that's it. Have a great day.